The Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the source and the observer move towards or away from each other. JC Doppler came up with this effect in 1842. He was a mathematician and a scientist. There are many everyday examples of the Doppler effect. One such example is the changing pitch of a police and ambulance siren. You hear the increased pitch of a police or ambulance siren approaching, and then a sharp decrease in pitch as the siren passes by. This is because as the vehicle approaches, the sound waves are closer together, meaning the pitch is a higher sound, and as the vehicle passes, the sound waves are further apart, meaning the pitch is a lower sound. Radar speed detectors use the Doppler effect. They bounce microwave radiation off of moving vehicles and detect the reflected waves. These waves are stifled in frequency by the Doppler effect, and the beat frequency between the directed and reflected waves provides a measure of the vehicle's speed. Light behaves like a wave, so light from luminous objects undergo a Doppler-like shift if the source is moving relative to us. Using the Doppler effect, we can tell if luminous objects such as stars are moving towards or away from the Earth. This is known as the redshift. When the star is at the red end of the spectrum, the waves are further apart, meaning it is receding or moving away from the Earth. If the star is at the blue end of the spectrum, the waves are closer together, meaning it is approaching or getting closer to the Earth. The Doppler effect can also be used in scans. A Doppler ultrasound test uses reflected sound waves to see how blood flows through a blood vessel. It helps doctors evaluate blood flow through major arteries and veins, such as those of the arms, legs, and neck. It can show blocked or reduced flow of blood through narrow areas in major arteries of the neck that could lead to stroke. During the Doppler ultrasound, the transducer sends and receives sound waves that are amplified through a microphone. The sound waves bounce off solid objects, including blood cells. The movement of blood cells causes a change in pitch of the reflected sound waves. A Doppler fetal monitor is used to detect the fetal heartbeat. It uses the Doppler effect to provide an audible simulation of the heartbeat. The Doppler effect can also be used in sonography. It is used to measure the speed and direction of the blood flow of a fetus. Sonic booms are directly related to the Doppler effect. They occur when a plane travels faster than the speed of sound. As the plane travels faster and faster, the sound waves at the front of the plane become more and more compressed until they form a barrier known as the sound barrier. When planes break this sound barrier, the sound waves no longer have time to disperse before the next one comes, so they overlap to form shock waves. These are known as sonic booms. If you are standing on the ground as a plane is travelling faster than the speed of sound, and it passes you, you will be hit by the edge of a wave front shaped like a cone. This is due to the successive spheres coming from the plane at the edge of the cone. All of the compressions merge together to form one giant sound. When the high pressure cone hits you, you experience it as a sonic boom.